Okay, so now we're going to go on with our plotting portion. And in this portion of the tutorial, what I decided to do was to go over the analysis of kinetics data and how we could plot kinetics data. But in particular, because later on in the semester, we're going to do an experiment where you have to distinguish between zero order, first order, and second order kinetics. And what I'm going to do is demonstrate how you can do that with Excel and using Excel, because that's what I'm going to ask you to do actually later on in the semester. So that makes this kind of a practical exercise that you could refer back to later. Now, the very first thing I've done is I pasted into Excel the data. I mean, you could just enter it in. We have a time versus the value. So basically, what this is the decomposition of A to B, right? So A is decomposing to B. And what we've got is we've got the concentration of A as a function of time. And so the very first thing that we would need to do in order to determine the order of reaction would be to plot. First, we'll plot this data, and then we will need to plot the data of time versus 1 over A, time versus the log of A. Now, for for zero order, then if this is a zero order reaction, this data would give us a straight line. So I'm going to go over just plotting this real quickly, and then we'll move on to the other portion. So what you would do is you select the data that you want to plot. You would come up to Insert, and you go to Charts. And here, plotting is best done by just doing a scatter plot. So we're going to just do a scatter plot. And you'll see at the top of our plot, it's labeled with what the x-axis, this is the y-axis. So time is on the x-axis, and concentration of A is on the y-axis. So that's basically this direction right here. And you can see clearly our data does not fit a straight line. So the graph, I've moved it up here, doesn't fit a straight line. How do you know that? Well, I want to demonstrate to you how to fit a trend line. So if you right click, all I did here is I'm just going to put the cursor over a data and I'm going to right click on it. When I do, it brings up a little drop down menu, and all I have to do is click on Add Trend Line. When I do that, it's going to bring this little menu up, and what I want to do is I want to make sure it's selected as linear, and I want to come down here and I want to select Display Equation, and I want to select Display R Squared. And I'll describe why in just a moment, but I want to put that on there first. So basically, we're going to move it up here where you can see it a little bit better. And so now we can see here's a straight line that has been fit to this data, but you can see the data points don't fit the line. And that's actually evidenced by the R squared. Because what R squared, if this data all fit the straight line, R square value would be 1, or very close to 1. The smaller the closer to 1 this value is, the better the data fits the line. That's the simple interpretation of it. So here's the equation for the best fit line, but this is how the best fit line fits, and it's very poorly. Typically, anything below 0.9 to 0.8 is typically a pretty bad fit. Things that are 0.95 and above R square values are actually pretty good fits. So this is a really bad fit. Now, I want to go through now with the rest of this demonstration is we've seen how to plot this, and we could, one of the things that I will do a separate little video on how to format a plot later, but let me go ahead and demonstrate to you for the purposes of this video how to do the rest of this, and I'll just have a separate video that I put on for formatting a plot. So now I want to go on and demonstrate how we would plot the other sets of data, because in this portion of the tutorial, I have said that you need to plot A versus time, but we also need to plot the natural log of A versus time. And we also need to plot 1 over A versus time to complete this part and be able to determine which order we have. Do we have a zero order, a first order, or a second order? And I'll explain what that means in terms of at least how to identify it in just a moment. So what we're going to need to do is now plot a set of data that is time versus the concentration of the natural log of the concentration of A. So what I'm going to do to make this a little easier is I'm just going to copy this and paste it down here. I'll go and I'm just going to paste the values, and then what I'll do is here I'm actually going to change this, and I'm going to call this the natural log of the concentration of A. And then what I'll do down here is I want to take and I'm going to enter in a formula. So I'm going to do natural log, which is ln, open parentheses, and then I'm just going to click on this cell right here and close parentheses. And then it places in this cell this value calculated as the natural log. Now, what I'm going to do is just copy that formula. And the way you can copy the formula, there's a couple ways. I can just highlight it and do copy, Control C, and then I can highlight the other cells and do Control V to do paste. And that will paste. An alternative method is just to put your cursor here and make sure it's a solid black cross like this, and then you can just drag that down. That does the same thing. So you can either copy and paste the old-fashioned way or use this newfangled way. Either way, now all of these values, even this bottom value, you can see right here, it's the natural log, and it's the natural log of this value. The concentration at 3,000 seconds, the natural log is of that 0.001 is negative 0.6908. Now, what I'm going to do is I want to plot this data. So I'm going to highlight it. I'm going to go up to Insert, Chart. Again, just the points, no lines in between them. And you can see here at the top of my plot, it has natural log. So this is the natural log plot, and natural log is over here on the side. My time is here on this axis. And then I'm going to put now here I'm going to fit a trend line just like we did before. I'm going to put the equation and the r square. And here we can actually see that our r-square value is actually quite good. It's actually very, very low for this. And so that's actually really good. And so our natural log function fits much better to this data set. And basically our trend line here is very close to 1. So this is very, very small. Now, what we're going to do additionally is we need to plot the 1 over this value, this data. So we've plotted just the concentration. Now we've plotted the log of the concentration versus time. And so I'm going to scroll down here, and what we're going to do is we'll just bring this on down. I'm going to put it down here, paste it down here. And then what we're going to do is we're going to change this to be 1 over the concentration of A. And now, so here I'm going to calculate 1 over, and where is the concentration of A for time 0? Well, that's back up here. That would be this 10 molar. So I click on that and hit return, and then that gives me the value right here. So you can see the formula is 1 over C3, which is this value. So I'm just going to drag that formula down all the way down like that. So that gives me 1 over the concentration data for all of that. Now I'm going to then plot this. I just highlight that. I will come up to our Insert, Chart, Scatter Plot. I'm going to bring it back down here, close to our data. I'm going to add a trend line, and then make sure it's linear, display the equation on the chart, display the R value, and then basically put it up here to where we can see it. And so now we can see that if we plot the data, this is the original data, but if we plot it in 3 different ways, okay, 3 different plots, and then fit a trend line to each of those, we're going to get this trend line, a straight line, does not fit the data very well. So for 0 order kinetics, this would need to be a straight line. If this data does not follow a straight line, this is not 0 order. So here we would say, This is not zero order. But when we plot the log of the data versus time, we do get a straight line. And so actually, this is first order. So this would be zero order, right? So zero order is just time versus the concentration gives you a straight line. Well, that's not true. Then here, to test to see if it's first order, we plot time versus the log of concentration. That does give us a straight line. So this means that we actually have a first order reaction kinetics going on, that this data is not zero order, but it actually represents first order kinetics. Now, what happens when we look at the second order? So that would be 0, first, and second is 1 over A, right? So this would be 0, this would be first, and then this would represent second order. And since this is not, when we fit the trend line, again, the R² value is not even close to 1. So this data does not, this 1 over concentration data does not fit a straight line. So this is not second order. So clearly, doing these 3 different plots demonstrates this is the only plot that has a straight line associated with it. That means that our kinetics data tells us that the reaction is a first order reaction. Now in class, later on in the semester, you'll learn what that means. What's the difference between 0, first, and second. But one of the ways in which you distinguish it is by doing these kinds of plots. And if you can plot the log of the concentration data versus time, and you get a straight line plot, then that tells you that your kinetics for this reaction is this is a first order reaction. And so that's what we demonstrate here. Now, suppose that we did this and this did not fit. This was like the points did not fit very good and our R² value was low, but this R² value for this was very close to 1, then that would mean that we had a 0 order. Or similarly, if you did a plot of the data and you plotted the 0, first, and second, like we've done here, and you get a straight line fit to the second order data, the straight line fit, that tells you, circle this, then that tells you that that was a second order, or that reaction has second order kinetics, because the decay rate depends on the concentration to the second power. But you don't have to understand that. All you have to understand for this tutorial is that if you plot just the straight data and you don't get a straight line, it's not 0 order. If you plot the log of the data versus time and you get a straight line, then it's first order. If you plot the 1 over the concentration versus time and you get a straight line, then it's second order. That's all you have to know for this tutorial to be able to identify 0, first, or second order. And when we come back to this later in the semester, you will have covered it in class and it'll make more sense to you. But for here, all you have to do for this tutorial and for your worksheet is plot the data 3 different ways. Plot 0, plot basically just the data, time versus the concentration. Plot time versus the log of the concentration. And this is again the log of these concentrations. And then plot time versus 1 over the concentration, and that would be 1 over these concentrations. So you're asked to do 3 different plots, and then from those plots identify whether or not your reaction kinetics are 0 order, first order, or second order. And of course, as always, if you have any questions, feel free to ask me.